Understanding the basics of hydraulics. Ever wonder how big, heavy machineries are able to move such heavy loads? Mining equipment, construction machinery, and any other industrial or mobile machinery that requires movement of heavy loads are often using hydraulic technology. To understand the basics of hydraulics, we can start by understanding pressure and Pascal's law. Pascal, as in French philosopher and scientist Blaise Pascal, who was born in June 19, 1623 in Clermont-Ferrand, France, and died in August 19, 1662 in Paris, France. Pressure is force exerted over an area. And Pascal's law says pressure applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid and to the walls of the container. The pressure at any point in the fluid is equal in all directions. For example, assume we have a 1-inch cube container. Each side of the container is 1 inch long, and each face of the container will be 1 square inch. And let's say we have a lid that seals the container, yet it is able to slide up and down inside the container. If we fill the container with water, and we close the container and try to push it down with the lid, the amount of force pushing down on the container will be transmitted without a change in magnitude through the water pushing in all directions against the walls of the container. If you apply 10 pounds of force pushing down on the lid of the container, you will get 10 pounds of force pushing in all directions against the walls of the container. The units to measure pressure are PSI, meaning pounds per square inch. In this example, we will have 10 psi of pressure pushing in all directions. Now, let's say we have a different container with two sides open. One side is 10-inch square area for the opening, and the other side has 50 inches square for the opening. If we push down with 100 pounds of force against the 10-inch square area, it will create equal pressure within the container pushing in all directions, and we will be able to lift a load of 500 pounds standing on the 50-inch square area of the container. Consider the hydraulic formulas of F equals P times A, or P equals F divided by A, in which F equals force measured in pounds, P equals pressure measured in pounds per square inch, and A equals area measured in square inches. If we have 100 pounds of force divided by 10-inch square, it will be equals to 10 psi. Now, if you take 10 psi times 50-inch square from the larger opening, it will be equals to 500 pounds of weight that you will be able to lift with just 100 pounds of effort coming from the smaller opening of the container. In this example, we are able to lift 5 times more the weight in relation to the effort pushing down on the fluid. However, we are only able to move 500 pounds, 1/5 of the distance in relation to the movement of the 100 pounds weight. If we push the 100 pounds weight 50 inches down, it will only move the 500 pounds weight 10 inches up. This is because the fluid displacement is the same on both sides of the container. 10-inch square area from the smaller opening times 50 inches round down distance equals 500 cubic inches. Same as 50-inch square area from the larger opening times 10 inches run up distance equals 500 cubic inches. In a hydraulic system, if you want to lift 4,000 pounds of weight and you have a cylinder that is 2-inch bore diameter by 1-inch rod diameter and 5-inch stroke, stroke is the distance in which you can extend and retract the cylinder, and the inch square area that you're going to use to push the rod in the cylinder would be 3.1416 inch square. The formula to calculate the area is diameter square times 0.7854 equals area in inch square. If we want to lift 4,000 pounds with this cylinder, we will use the formula P equals F divided by A. So we have 4,000 pounds divided by 3.1416 inch square equals 1,273.2365 psi. If we input, say, 2.042 GPM or gallons per minute into the cylinder at a minimum of 1,273.2365 psi, then the cylinder will extend and lift 4,000 pounds. But what if you want to lift 8,000 pounds instead? Then you can say 8,000 pounds divided by 3.1416 inch square equals to 2,546.4731 psi. You could just increase the working pressure. But, big warning, before increasing pressure in the system, you need to make sure all hydraulic components are rated to the pressure you're working with, or your system might just blow up like this. Boom! So, if you don't want your hydraulic system to blow, you might just want to keep the maximum pressure within the pressure rating of your components. Say this particular system has a max working pressure of 1,500 psi. Then you will need a bigger area cylinder to lift the higher load to stay within the limits of your system. Say a cylinder that is 3 1/4 inch bore by 1 3/4 inch rod by 5-inch stroke. The working area to push the rod in this cylinder will be 8.2958 inch square. That is a rounded figure. We have 3.25 square times 0.7854 equals 8.2957875 inch square for the area of this new bigger cylinder. The new numbers in the formula to calculate pressure for this cylinder will be 8,000 pounds divided by 8.2958 inch square equals 964.3434 psi. So if you input 2.042 GPM at 964.3434 psi into your new cylinder, then the cylinder will lift a load of 8,000 pounds. But if you will notice, the bigger cylinder moves slower than the smaller cylinder, and that is because you're using the same flow rate of 2.042 GPM for both cylinders. The bigger cylinder has more area, and it will take more time to extend the cylinder with the same flow rate as the smaller cylinder. How can we calculate proper flow rate for the bigger cylinder to move within a certain speed that we want? Please make sure to like and subscribe as we will continue our hydraulic basics on next videos. Thank you very much for your attention.